So why do most AI apps completely fail? It's probably not what you think. It isn't the model, it's the engineering. Today, we're going to break down the 3 core frameworks that separate a real AI system from just an expensive toy, and how getting them right can save your company almost $200,000 a year.
Okay, let's start with a number that should honestly keep you up at night. Research from MIT shows that a massive 95% of AI projects fail to create any real, lasting value. They look great in a demo, right? They work fine in the lab, but when they hit the real world, poof, they just fall apart.
So what's going on here? Why this huge failure rate? Well, it boils down to something pretty simple. Teams are building toys when they need to be building systems. A toy is a cool prototype. It works for a handful of users, costs a few bucks. A system? That's built for millions of requests. It's built to scale efficiently and, not bankrupt you. And the key difference isn't the AI model you choose, it's the engineering behind it.
To get from toy to system, you've got to master 3 fundamental engineering frameworks. First up is HLD, or high-level design. That's your architecture, your blueprint. Second is LLD, low-level design. That's your code, your implementation. And finally, DSA, data structures and algorithms. That's all about making it run fast and cheap. These 3 pillars are exactly what we're going to tear down today.
All right, let's jump into Part 1, HLD. Think of this as your system's skeleton. High-level design is all about finding the weak spots, the choke points, before they snap in half the second you get a little bit of traffic. It's all about asking, what's going to break when we go from 10 users to 10,000? So, what's the absolute biggest, most expensive mistake people make here? It's this. Sending every single user query straight to the LLM. You're completely skipping a caching layer. I mean, think about it. In the real world, something like 70% of the questions your users ask are just slight variations of each other. Hitting your expensive LLM for every single one of those, you are literally just lighting cache on fire. The fix is something called a semantic cache layer. And here's how it works. Pretty slick. Instead of going straight to the LLM, every question first gets turned into a vector embedding. Basically a string of numbers that captures its meaning. Then, you check a fast database to see if you've answered a similar question before. If you find a match, you just send back the old answer. Boom! The LLM never even gets the call.
And the results? They're not just good. They are absolutely insane. Check out this benchmark. Without a cache, you're waiting over 6 seconds for an answer. With a semantic cache, it's under 2 seconds. And for an exact match, a blazing fast 53 milliseconds. We're talking a speed up of up to 123 times, not to mention the huge drop in API costs. This one piece of architecture is a total game changer.
Okay, so we've got the skeleton sorted. Now let's build on it with Part 2, low-level design. This is the muscle of your system, the actual code. You can have the best architecture in the world, but if your code is sloppy, your costs are going to go right through the roof.
The #1 killer in LLD for AI apps, especially agentic ones, is this thing called state bloat. In those workflows where the AI is having a back-and-forth conversation or doing multiple steps, well, the state or the memory of that conversation can grow like crazy with every turn, and that gets expensive fast.
And you can really see the difference here. The toy approach is, well, it's lazy. You just stuff the entire conversation history, every message, every tool output, back into the LLM on every single turn. That can easily hit 1,000 tokens per step. The production approach, though, is way smarter. It uses what's called a state machine to only pass the current goal and the most relevant bits of history, shrinking that context down to just 50 tokens.
And what does that mean for your wallet? At scale, that lazy toy approach could cost you $20,000 a day. The lean production approach, just $1,000. That is a 20x cost reduction simply from being intelligent about how you manage state in your code. That, right there, is the power of good LLD.
All right, last piece of the puzzle. Data structures and algorithms. DSA. If HLD is the skeleton and LLD is the muscle, this is the brain. This is the efficiency layer that separates a reliable system from, well, a chaotic mess. Let me just paint you a picture that happens all the time. A free user starts spamming your API with 1,000 requests. Right after, your biggest enterprise client, the one paying you 10 grand a month, sends one important request. With a basic first in, first out queue, your best customer gets stuck waiting. They wait 5 minutes, and then they cancel their contract. That's a business-ending mistake.
So, what's the production level fix? It's a priority queue.
This is a classic from Computer Science 101. Instead of first come, first served, it operates on most important first served. It lets you sort requests by things like customer value, making sure your VIPs always get to jump to the front of the line. And get this, it's unbelievably efficient because it works in what's called logarithmic time. Sorting a line of 10,000 requests doesn't take 10,000 operations. It takes about 14, just 14. That's how you build a system that's both fair to your best customers and incredibly fast at scale.
Okay, so we've covered the skeleton, the muscle, and the brain. Let's put it all together now and see what the real combined impact looks like. This is where it all clicks.
This table just lays it all out. Your toy system on one side. No caching, bloated state, dumb queues. The result? A $20,000 monthly bill and a laggy 500 millisecond response time. Then you have the production system, semantic caching, lean state, and priority queues. The bill plummets to just over $4,000 a month, and the latency is cut down to under 100 milliseconds.
So what does that all add up to over a year? $190,000. That isn't just a minor optimization. For a startup, that is your runway. That's the difference between running out of cash and raising your Series A. It's the tangible, cold hard cash value of engineering discipline. And so, I'll leave you with this one crucial question you need to ask yourself. Are you building a fragile, expensive toy that's destined to join that 95% that fail? Or are you building a controlled, cost-efficient, and reliable system that's ready for production? The choice really just comes down to applying these engineering principles.